Good morning, grade 7 learners. I hope you are all doing good because this is a new day for you to learn, explore, and discover more about science. Before we start our session, let me give you these three important reminders. First, prepare your module and writing materials. Second, focus and listen attentively in our discussion. And lastly, participate actively using comment section. For the most essential learning competency, you are expected to describe the motion of an object in terms of distance or displacement, speed or velocity, and acceleration. Specifically, you are expected to describe the speed, velocity, and acceleration of moving objects. Second, differentiate speed, velocity, and acceleration. And last, solve word problems involving speed, velocity, and acceleration. In the previous discussion, we learned about the principle of motion and the differences between distance and displacement. Before we proceed with our lesson, let us have first a recall of the previous lesson to find out if you still remember our last topic. I will read the question carefully and give you 5 seconds to figure out the answer. Use the comment section to type in your answer. Are you ready? Let's start. Question number 1. What do you call a change in position with respect to a frame of reference? Your time starts now. Please key in now your answer in the comment section. Time's up. All right, let us now reveal the answer. And the answer is motion. Very good, grade 7 learners. We can say that an object is in motion if it changes its position from one place to another. Let us proceed to question number 2. What scalar quantity is used to describe the actual path traveled by a moving object? Please key in your answer. Time's up. And the correct answer is distance. Distance is a scalar quantity that describes the actual length of path taken by a moving object. You're doing great, grade 7 learners. Now, let's go to question number 3. A Philippine mouse deer, also known as pilandok, was observed by a tourist in captivity in Palawan. It walks 5 meters going east, 5 meters going north, 5 meters going west, and 5 meters going south. What is the total distance traveled by a pilandok? Please type in your answer. And the answer is 20 meters. To compute for the total distance, we simply add all the paths traveled by a moving object or body regardless of the direction. Let us proceed to 4th question. What vector quantity is used to describe the total path length covered by a moving object in a specific direction? You may now key in your answer. Time's up, and the answer is displacement. Remember that displacement refers to the shortest path between starting point and end point of motion. And for our last question, a tamaraw from Mindoro was observed to move 10 kilometers east, 10 kilometers north, 10 kilometers west, and 10 kilometers south. What is the total displacement traveled by the tamaraw? Use the comment section to type in your answer. Time's up. Let us now reveal the correct answer. And the answer is 0 kilometer. Based on the problem, the starting point and the end point are at the same position. If we measure the path between starting point and end point, the answer would be 0. Very good, grade 7 learners. You are all excellent. At this point, let us identify objects or bodies that are in motion. In doing so, I would like you to take a look at this short video. I will give you 30 seconds to identify and type in the comment section all of the moving objects or bodies that you have observed. Let's reveal the answer. The objects or bodies moving in the video are the birds, leaves, water waves, people, and the boat. Good observations, grade 7 learners. Based on the video clip, those objects or bodies differ in speed, velocity, and acceleration. With that, I know you are now all ready to pay attention to our new lesson. The focus of our discussion for today is all about speed, velocity, and acceleration. But how will you describe how fast an object or body moves? Let us discuss the topic one by one. Speed is a scalar quantity that defines as the distance traveled by a moving body in a given time. Look at the motion of a car. It is moving at a certain speed but no constant direction. In terms of speed, we only consider the distance traveled and the time it takes to complete its movement. Remember, direction is not important in speed. Mathematically, speed is equal to distance over time. In symbol, S is equal to D over T. Try to use this triangle method in solving the unknown quantity in a problem. Assume that the missing quantity in a problem is the speed. Cover the speed with your finger, then you will have D over T. Divide distance time to solve for speed. If you cover D, that stands for distance, then you will have an equation for distance which is S times T. Just multiply the value of speed and the value of time to each other to get the value of distance. If you cover T with your finger, you can have T over S. Divide the distance to speed to solve for the unknown time. Let us try to solve sample problems step by step. Sample problem number 1. How fast should a Visayan WRTP run to cover a distance of 100 meters in 5 seconds? First, let us find out what is being asked. Based on the problem, we have to answer the question, how fast? How fast denotes speed. Speed is the unknown quantity. Second, we will identify the given quantities. Our given in the problem are distance and time, where distance is equal to 100 meters and time is equal to 5 seconds. Third, we need to identify the equation to solve for the unknown. The equation to be used is speed is equal to distance divided by time. Then fourth, we are going to substitute the given quantities in the equation wherein speed is equal to 100 meters divided by 5 seconds. The answer is 20 meters per second. This is the speed of the Visayan WRTP if it runs 100 meters in 5 seconds. Next problem. A Philippine eagle was observed to fly at an average speed of 120 kilometers per hour in 2 hours. How far did it travel for the whole period of time? We will do the same procedure in solving problems. First, let us find out what is being asked. Based on the problem, we have to answer the question, how far? How far denotes distance. Distance is our missing quantity. Then second, we will identify the given quantities, and these are speed, which is equal to 120 kilometers per hour, and time is equal to 2 hours. Third, we need to identify the equation to solve for the unknown. Our equation is distance, which is equal to speed multiplied by the time. Fourth, we are going to substitute the given quantities in the equation. Distance is equal to 100 kilometers per hour multiplied by 2 hours. Remember, as we multiply 120 kilometers per hour by 2 hours, we need to cancel the unit of hours to come up with the unit of distance, which is kilometer. And the answer is 240 kilometers. Okay, grade 7. Now, it's your turn to answer this problem. An aspin, a Philippine dog, should run at 15 meters per second to cover a distance of 105 meters. How long should it run? I will give you 30 seconds to answer this problem. If you are done, you may type your answer in the comment section. Your time starts now. Time's up. First, let us find out what is being asked. Based on the problem, we have to answer the question, how long? How long denotes time. So our time is the unknown quantity. Second, let us identify the given quantities, and these are speed and distance. Our distance is equal to 105 meters, and the speed is equal to 15 meters per second. Third, we need to identify the equation to solve for the unknown. Our unknown is time. Time is equal to distance divided by the speed. Fourth, we will substitute the given quantities in the equation. Time is equal to 105 meters divided by 15 meters per second. Let us cancel the unit meter to come up with the unit of time, which is second. Then, our answer is 7 seconds. Great, grade 7 learners, you've got the correct answer. In every road, there is a speed limit. For example, in major highways like expressways, the speed limit is 100 kilometers per hour. In minor highways like MacArthur Highway, the speed limit is 60 kilometers per hour. In primary roads, the speed limit is only 40 kilometers per hour. Do you know how vehicles measure their speed? In every car, there is a device called speedometer. This device is required for all vehicles with engines. It prevents the drivers from overspeeding. Also, it measures the instantaneous speed of vehicles. Instantaneous speed is a speed at a particular instant. This is the speed registered by an automobile's speedometer. Most of the vehicles cannot maintain a constant speed, but drivers can monitor how fast they are moving. Let us now proceed to velocity. Velocity is the displacement traveled by a moving body in a given time. Remember, that the only difference between speed and velocity is the direction. Speed has no direction, while in velocity, direction is important. Look at the motion of a moving car. It is moving in a straight path and constant speed. It only means that the velocity of the car is constant. Remember, the direction is important in velocity. Mathematically, velocity is equal to displacement divided by the time it takes to complete the travel. In symbol, V is equal to D divided by T. If you notice, there is an arrow on top of D. The arrow represents direction. Let's use the triangle method to analyze the equation for velocity. V stands for velocity, D stands for displacement, and T stands for time. Assume that the missing quantity in a problem is the velocity. Cover the velocity with your finger. Then we'll have D over T. Divide the displacement by the time to solve for velocity. If you cover D, which is the displacement, then you will have an equation for displacement, which is V times T. Just multiply the value of velocity to the value of time to get the value of displacement. If you cover T with your finger, you can have T over V. Divide the displacement to velocity to solve for the unknown time. Let's try to solve sample problems involving velocity. Are you ready? Sample problem number 1. The Department of Science and Technology has created the first Filipino-built train, the Hybrid Electric Train, or HET. Its destination is from Metro Manila to Calamba, Laguna. If it would travel at a velocity of 60 kilometers per hour for 1 hour to complete a one-way trip, how far is Metro Manila from Calamba, Laguna? Assume that it travels at a constant velocity. First, let us find out what is being asked. Based on the problem, we have to answer the question, how far? How far represents the displacement. The unknown is the displacement. Next, we need to identify the given quantities. Our given quantities are velocity, which is equal to 60 kilometers per hour, and time is equal to 1 hour. Next, we need to find or identify the equation to solve for the unknown. Displacement, which is equal to the product of velocity and time. Fourth, we will substitute the given quantities in the equation. Remember, cancel the unit for time, which is r, to come up with the correct unit for displacement. Displacement is equal to 60 kilometers per hour times 1 hour. And so the answer is 60 kilometers. And for sample problem number 2, a car travels from north to south. It has a maximum velocity of 60 kilometers per hour. How long should it travel to cover 30 kilometers? First, let us find out what is being asked. Based on the problem, we have to answer the question, how long, which represents time. The unknown quantity is time. Second, let us identify the given quantities. Our given quantities are velocity and displacement, wherein velocity is equal to 60 kilometers per hour and the displacement is equal to 30 kilometers. Third, we need to identify the equation to solve for the unknown, which is time. Time is equal to the displacement divided by velocity. Fourth, we will substitute the given quantities in the equation. Time is equal to 30 kilometers divided by velocity, which is 60 kilometers per hour. Again, cancel the unit of kilometer to come up with our missing quantity for time, which is r. And the answer is 0.5 r. Excellent, grade 7. Now, it's your turn to answer this problem. A sports car can travel 1,650 kilometers in a straight track from starting point to end point. If it travels for 5 hours, what is its velocity? I will give you 30 seconds to answer this problem. If you are done answering, type in your answer in the comment section. Your time starts now. Time's up. Let us now reveal the solution and answer. First, let us find out what is being asked. Based on the problem, we have to solve for the velocity of the sports car. Velocity is the unknown quantity. Second, we need to identify the given quantities. The time is 5 hours and the displacement is 1,650 kilometers. Third, we need to identify the equation to solve for the unknown. Velocity is equal to displacement divided by time. Fourth, we need to substitute the given quantities in the equation. Velocity is equal to 1,650 kilometers divided by 5 hours. The answer is 330 kilometers per hour from starting point to end point. Were you able to get the correct answer? If you do, then you did a great job. Let us now proceed to our next topic, which is acceleration. To describe quantitatively how an object changes velocity in a particular time, we use the term acceleration. Acceleration is the rate of change in velocity per unit of time. Acceleration is not the total change in velocity alone, but it also includes the time rate of change. Changing the velocity means changing the speed or direction or both. Look at the next slide. A bee is moving at a constant direction, but the speed is changing. Therefore, it is accelerating. This slide shows a bee moving at a constant speed by a changing direction. It only means that the bee is still accelerating. If a bee flies at changing speed and changing direction, it is still accelerating. Remember, if there is a change in speed or direction or both, moving object or body is accelerating. Mathematically, acceleration is equal to the final velocity minus the initial velocity divided by time. In symbol, A is equal to delta V divided by T. Since delta V is equal to final velocity minus the initial velocity, then A is equal to final velocity minus the initial velocity divided by time. Let's try to answer sample problems to understand acceleration mathematically. Sample problem number 1. A race car at rest suddenly moves at 20 meters per second in 5 seconds. What is the acceleration of the car? First, let us find out what is being asked. Based on the problem, we have to solve for the acceleration of a racing car. Acceleration is the unknown quantity. Second, identify the given quantities. The racing car starts from rest. It means that its initial velocity is 0. Its final velocity is 20 meters per second, and the time of change of velocity is 5 seconds. Then third, we need to identify the equation to solve for the unknown. The equation that we will use is A is equal to V sub F minus V sub I over T. Fourth, substitute the given quantities in the equation. Acceleration is equal to 20 meters per second minus 0 meter per second divided by 5 seconds. Therefore, The acceleration of a race car is 4 meters per second squared. Sample problem number 2. A truck moving at 40 meters per second reduces its velocity to 20 meters per second in 5 seconds. Compute for the deceleration of the truck. If a truck slows down, we will assume of negative acceleration. This is also known as deceleration. First, let us find out what is being asked. Based on the problem, we have to solve for the deceleration of a truck. The unknown quantity is acceleration. Second, we will identify the given quantities. The truck starts from 40 meters per second and its final velocity is 20 meters per second. The time of change of velocity is 5 seconds. Third, we need to identify the equation to solve for the unknown quantity. The equation that we will use is A is equal to V sub F minus V sub I divided by T. Fourth, we will substitute the given quantities in the equation. Acceleration is equal to 20 meters per second minus 40 meters per second divided by 5 seconds. 20 minus 40 is negative 20 divided by 5 seconds. Then the acceleration of the truck as we solve it is negative 4 meters per second squared. Why? Remember, if a moving object slows down, then it has a negative acceleration, or we simply call it deceleration. Okay, grade 7. Now it's your turn to answer this problem. In 3 seconds, a cat changes its velocity from 6 meters per second to 15 meters per second. Solve for the acceleration of the cat. I will give you 30 seconds to answer this problem. If you are done, type your answer in the comment section. Time starts now. Time's up. Let us now reveal the solution and the answer. First, let us find out what is being asked. Based on the problem, we have to solve for the acceleration of a cat. The unknown quantity in the problem is the acceleration. Second, identify the given quantities. Our given quantities are the initial velocity of the cat, which is 6 meters per second. Its final velocity is 15 meters per second, and the time of change in velocity is 3 seconds. Third, we need to identify the equation to solve for the unknown. The equation that we will use is A is equal to V sub F minus V sub I divided by T. Fourth, substitute the given quantities in the equation. Acceleration is equal to 15 meters per second minus 6 meters per second divided by 3 seconds. The acceleration of the cat is 3 meters per second squared. The acceleration of the cat is positive because the final velocity is greater than the initial velocity. Or we can say that the cat speeds up. Were you able to get the correct answer? If you do, then you did a great job. Now, it's time to wrap up our new gained knowledge for today. Speed is the distance traveled in a given time. It is a scalar quantity because it does not involve direction. The equation for speed is distance divided by time. Velocity is the displacement traveled in a given time. It is a vector quantity because it involves direction. The equation for velocity is displacement divided by time. The arrow on top of D represents direction. Acceleration is the change in velocity per unit of time. It is wrong to say that acceleration is the change in velocity alone. Time must be considered in changing the velocity. There are two types of acceleration. One is positive acceleration, or simply we call it as acceleration, and the other one is negative acceleration, or we simply call it as deceleration. Positive acceleration happens only if the velocity increases. Deceleration happens only if a moving object slows down or reduces its speed or comes to a full stop. To check your understanding about the lesson, let's have a short activity. For the first 3 questions, I'm giving you 5 seconds for each to answer. And for the last 2 questions, I'll give 20 seconds for each. Are you ready? Let's begin. Answer the following questions. Question number 1. Which quantity represents distance traveled in a given time? Your 5 seconds starts now. Time's up. If your answer is speed, you are excellent. Speed is a measure of the quantity of a distance traveled in a given time. Question number 2. What quantity measures the displacement traveled in a given time? Your 5 seconds starts now. Time's up. If your answer is velocity, you are correct. The difference between the speed and velocity is direction. Speed has no direction while velocity has. Question number 3. What is the change in velocity per unit of time? Your 5 seconds starts now. Time's up. If your answer is acceleration, you answer it correctly. Acceleration can be positive or negative depending on how it will change its velocity with respect to time. Question number 4. What is the velocity of a car moving in a highway if it travels 100 kilometers in 2 hours? Your 20 seconds starts now. Time's up. If your answer is 50 kilometers per hour, you did it well. Question number 5. What is the acceleration of a truck moving from 5 meters per second to 10 meters per second in 2 seconds? Your 20 seconds starts now. Time's up. If your answer is 2.5 meters per second square, you are excellent. Congratulations, grade 7 learners. Now, it is time for our question and answer portion. You have 30 seconds to key in your questions. From Kanumay East National High School, Sir, what will happen to the velocity of a person who jumped off from a plane? This is a good question. If a person jumped off from a flying airplane with a very high altitude, its velocity increases. But when he reaches his terminal velocity or maximum velocity, his velocity will become constant. Let's read another question. From Bagbagi National High School, will there be an acceleration even if a car has a constant velocity? So the answer is no. Acceleration is a change in velocity in a given time. The speed or direction or both must change to accelerate. And last question from Polo National High School. What other explanation can be given for a negative acceleration? By considering the directions of velocity and acceleration, deceleration takes place if the direction of velocity is opposite to the direction of acceleration. So that's it for now. For your queries, you may address it to your science teacher during your follow-up discussion. There you have it, grade 7 learners. And for your assignment, kindly answer the activities on pages 10 to 14 of your science module. I hope you learned a lot and had fun with today's lesson. Thank you for listening and participating in our class today. Always keep safe and try to stay at home. God bless everyone.